Welcome to a new video on my home automation Open Hub and Node-RED series. If you watched my previous video on making a PCB, I mentioned that I was doing that PCB just to try out before I actually design my, let's say, production version PCB or printed circuit board. And that's actually this one. So in this video I'm going to talk about this sensor module, which is nothing else than a DHT22 temperature and humidity sensor, an ESP826601, so the small ESP board, and the rest of it is just basically power supply for the mains. A friend of mine asked me to create 10 temperature sensors for his workshop to place it around in various places in the workshop. And I thought that, well, that's a project for which I need a PCB, because I would rather not do 10 on perf boards or various other methods. So I've actually taken the time to learn how to design a PCB. I contacted PCBWay, and they are sponsoring this video in terms of manufacturing the PCB for me for this board. And in this video I'm going to talk about the PCB that I designed for this board, and well, some of the hiccups that I had along the design, and how I actually built this, and some of the things that I took into consideration when designing this board. And of course, at the end of the video, I'm going to flash the ESP8266 so it runs my Blynk sketch. I already have a project in Blynk which has a device, so I will be adding these 10 temperature sensors to the same project, and of course add the UI elements to display the temperature and the humidity. If you like this project and if you want to build your own, I'm going to leave a link in the video description which links to this PCB project in PCBWay, so you can actually order your own PCBs, well, exactly the same PCBs as mine, and then build the same project yourself. I have to be honest, I haven't expected this to turn up so quickly, but actually it was shipped with DHL. So the manufacturing is usually just a few days, and then shipping was again also just a few, hence the really quick delivery. So it comes in the same box as what I got before, and I ordered 15 boards because I need to make 10 temperature sensors, and actually I think this is going to be quite a useful board, so I'm just going to keep the others for myself. So if we open this up, geez, this is packed well. Okay, so here I tried something new, which you are going to see quite soon. So you can see the boards here. Let me zoom in a little bit. Okay, wonderful. So fairly simple board, ESP826601, that's the DHT22 sensor, the power supply, the inline fuse connector for the mains input, and the MOV, and a smoothing cap. Oh, and of course a pull-up resistor for the DHT22. And that's pretty much it. And a new feature that I tried out in this board is a ground plane. You can see this big plane here, because I'm trying to educate myself how to design PCBs, and apparently it's a good practice to design big ground planes so all the ground points are linked together by one big plane, so they have so the electrons have a low impedance path, and I think it also reduces noise. And so what I've done here is there is one ground plane on one side and there is another one on the other side, and this is the actual ground plane on this side, and then the other one is the VCC, so the 3.3 volts. And I've already spotted a mistake, and it's going to be really painful. So I'm going to cover this in another video, but when you design a ground plane, you basically specify all the points that should be linked by the ground plane. So let's say all the ground points. So in this case, that's my ground point. There is a ground point here on the smoothing cap. There is one on the DHT, and there is one on the ESP8266 as well. And then when you specify that I want to flood this area, then the software knows which points to connect and then which one to do sort of like an exclusion zone around. So you can see here that the ground plane is pulled away from these pins. And of course they apply the solder mask as well. So in most cases the this copper is well, basically protected with this green bit, and it's only visible here. And when you are making changes to a layout, there is a function to regenerate the ground plane. And at the end, I decided to move this resistor a little bit closer to the ESP. But that was after I have regenerated the ground plane. So you can see that that was the original place of the resistor. So it was there. So from here, so basically from here I moved it further in. But now the ground plane is generated as per the old position of the resistor, also here, which means that my resistor is incorrectly connected to the ground plane. Well, it's only this pin, because this one is supposed to go to, and actually this is the VCC. So, you know, when you are using a DHT22, you need to pull the data line up to VCC using a 4.7K resistor. So this is what I have done here. But now, because of the way the this ground plane is, or basically this plane is generated, this is also connected to VCC. So, Jesus, I need to delete that piece of copper around that pad and do it 15 times. So, that's going to be painful. And again, this is why I designed another board. So I go through the teething issues and you know, the traps, and I managed to get into another one on my you know, so-called production board. So not nice. As you can see, the sensor factory has been at full swing in the last couple of days, and that's what I've been doing in the evenings for, I don't know, maybe just a bit about 2 days. I usually just turn on some YouTube videos, for example, kernel failure driving trains in the and I start soldering them. So the first thing that I've done is I modified the board and I fixed the design issue that I unfortunately put into the files when I ordered them. But it wasn't too bad. I just had to drill out the two pads for the resistor with a 2mm bit. Because they were basically connecting this plane, which is, I think that's VCC 3.3 volts, and the other one which is ground. You can see that the two, basically the holes were not aligned here. And so that made sure that I'm not shorting the plus and the minus terminals of the power supply anymore. And I just had to scrape off a little bit of the solder mask, which reveals the copper underneath. And once I have done that, I could solder the resistor in like a surface mount. But that was the only thing. I fitted all the other components, and this is how the board looks like without the DHT and the ESP01. And actually my eBay source was running low on these power supplies, so I only have 4 out of the 10 that I need. But I soldered the rest of the components into the board, so, and this is a finished one. And as you can see, I have probably picked the smallest project box for this, because it's, you know, it's pretty cramped, but it's still, you know, good enough. I mean, I can have access to most of the components, and the whole board is screwed down to these mounting holes on the board. I don't have a lot of space for the cables, and I'm probably just going to use a cable tie for strain relief. And yeah, but that's it. The only reason I'm not going to talk about the circuit in detail, because I'm not really an electrical engineer. So the only thing I knew that, because I only need a temperature and humidity sensor and I wanted to keep the price down, I opted to use the ESP01. I mean, previously on all my projects I'm using VMOS D1 minis, but because I don't need the extra pins, I thought I can just go for the cheapest possible option, which is the ESP01. And I also use these HLK power supplies a lot, and they have a 3.3 volt version, so that's the HLK PM03, which outputs 3.3 volts, ideal for the ESP01. And I did a little bit of research online on how to use this power supply and what additional components you might need. And I've actually also built a prototype model where basically I just wired all these pieces together. And if you just use this power supply, hook it directly up to the ESP01 without any smoothing or caps and everything, it works. And that circuit worked reliably for, you know, multiple days, so I wasn't too worried about that. But as I said, after doing a little bit of research, I found that in most cases, people usually add a filter cap on the 3.3 volt side, just to make sure that the power supply is stable enough for the ESP. Also, it's a good idea to add an inline fuse on the main side, and also add a MOV to clamp any of the transients. And because this is going to be in a workshop where there are a lot of power tools and welders and I don't know, a lot of powerful machines, I thought it actually makes sense to add these protections. If you are using that in your home, yeah, you can probably leave the MOV out. You just don't solder it in. And if you don't want to use a fuse, I mean, it's just a couple of bucks. It doesn't cost a lot. But if you don't use the fuse, then you can just replace the fuse with a piece of wire, I mean, on the board. And that should be it. You can plug the DHT22 in here or solder directly in if that's what you want. But I just solder this pin header on and a piece of wire to the DHT22, and I just drilled a hole, and that's how I mounted it outside with a piece of double-sided tape which has a bit of sponge in between, so that's probably further insulates the and prevents heat transfer between the case and the sensor. And I think that's fine. I mean, the only thing is that with this I drilled a really small hole, so I had to fed the wires through and then solder on the pin header. So it's the only way to replace it is just to cut these and then resolder them. And also I could have used the JST connector here, so I wouldn't have to worry about the polarity. And also probably the JST plug comes with a piece of wire soldered onto it, so I could have reduced some of my manual labor, but well, these are the components that I had at hand. So let's start with the software side of things, and I have the Blynk example browser loaded. I also have opened Arduino. I just opened a new sketch, but before I do anything, I need to start Blynk. And as I said, I'm going to be making some changes to an existing project. So this is the project that I've opened, and it already has a temperature and the humidity sensor. So I'm just going to add, sorry, not this one, but I'm going to add a new device. Yeah. So these are the devices, and I want to add a new device. Hopefully there's no limit on the devices, like there's no limit on, I don't know, 5 or something. So this is going to be Hungarian, but I think you can figure out the details. Okay, so we are going to use an ESP8266, and we are going to use Wi-Fi, and I want to email myself the authorization token, so I'm just going to click on create. Okay, token was sent. So we have 2 devices, and that's fine. So that should be enough for the project. Actually, since I'm here, I might just whack in the new controls. So I'm going to need it's been some times when I was in Blynk for the last time. So I need to display a label value. Oops. And it's going to be my sensor 1. And it is going to define a virtual pin. And I've looked at the code, and I've already know that the code puts in, let me do some cheating, yeah, so it uses virtual pin 5 and 6. So virtual pin 5, V5 is for humidity. And the other thing I want to do is, so I just renamed it as humidity, and in the label I put /pin ./ and %, and this instructs Blynk to format the value to take out the decimal places, because the DHT22 is not, it's probably only accurate to about 5% humidity, so there is no point showing 0.1% humidity, because it's not going to be accurate enough. So it's going to be just even numbers of humidity. Okay, so that's how it's going to look like, and I just need to create a new one for the temperature. So that's going to be a labeled value as well, and this is going to come down here, and that would also use the sensor 1 and virtual pin 6, and that's going to be temperature. Or this is how you format temperature readings with 1 decimal place and degrees centigrade at the end. So that should be it about setting up the new sensor. So we can leave Blynk. Actually, I can start this project running, and it's going to show you that the sensor 1 is not online yet because we, well, haven't made it online. So I can close this one for now, keep this running, and I can start looking at the code. So as I said, I opened the Blynk example browser. Here on the left, I specified that I have an ESP8266, which is using Wi-Fi, and I need a DHT11 example. So that's fine. I mean, that's basically, this is all we need. So I just select the code and then copy it over to my sketch here. Actually, I'm going to delete most of the comments here. And I need to start making some changes to the code. So first of all, I'm using a DHT22. So I'm just going to uncomment 11 and I'm comment DHT22. I don't really have to use any or make any changes here. You see the comment here, so DHT.read temperature. If you want in Fahrenheit, you just put true here. And as I said before, I've looked at the code, so I know that they are passing the humidity to virtual pin 5. So passing, and sorry, that's 5, and the temperature to 6. So this is why I used virtual pin 5 and 6. And that's pretty much it. Yeah, and then here there is a timer set up, so that basically calls the send sensor function, which reads the DHT22 sensor and sends the readings to Blynk, and it is set up to 1000 L, so that's in milliseconds. So that would be called every second. And honestly, I don't need, well, maybe for testing purposes, I will just keep it 10,000 L. So I will be sending messages every 10 seconds. So basically, temperature and humidity updates every 10 seconds. Honestly, in a production one, I think I'm going to change that to 30,000. So yeah, twice every minute. I think that should be more than enough. So the only thing which you have to do is basically put in your SSID, so that's your Wi-Fi name and your Wi-Fi password, and the authorization token that we probably just received. So that was the email sent by Blynk when you created the new device. So just basically paste the authorization token in here. So I quickly made the changes, and now I just need to set up my board, which is going to be, where are my ESP boards? So many of them, I think it's further down. For some reason, uploading the firmware didn't go for the first time, so I just clicked on play again. So now we need to lower the baud rate. That's it. And okay, so our Blynk is connected to our Wi-Fi, and it says it's connecting to the Blynk cloud. And it's failed to read the temperature from the DHT sensor, which obviously makes sense because it's not connected to anything at the moment. But if we go back to our app now, our app is not complaining about the sensor being offline. So as you can see, both of the ESPs are now online. So now that the programming is done, I can just unplug the programmer. And as you can see, it's a simple USB on one end, and it has this 2x4 header here. You just plug the ESP like this. And it also has a small switch, which I slide to the programming setting. So you can do the programming of the ESP. So simple as that. So we don't need that anymore. And I can just, plug the ESP back into the boards. And now I can plug it into mains, and it can start sending readings. And as you can see, it is working now. So we have the device connected again, and we have started receiving temperature and humidity readings. So the first node is working, only 9 more to go. And this is the page where I shared my PCB design. I'm just going to leave this link in the video description. You can see it shows you the same layout what I have ordered for myself. Obviously the only difference is that I have corrected the mistake around this resistor, and here you can see that the legs of the resistor are aligned with the holes in the copper plate. So that issue that I had on my copies are definitely corrected. The only small addition I made is I have also added some labels here which I forgot from my design. So it clearly shows the VCC, the data, and the ground line. So if you plan to use a different sensor, then at least you know which pins are connected to which. But I mean, I have 4 pins here because the DHT22 has 4 pins as well, but it's also using only 3 pins, so this pin is not connected to anything. And more importantly, further down in the description of this page, I've included the eBay links to all the components that I used here, with the exception of the few which I purchased in local stores. So you just have to find an equivalent product, or either on eBay, or just head down to your local electronics stores and buy them there. Thank you very much for tuning in. There are a couple of thumbnails now on the screen, so you can watch some of my other content, or you can also click on my lovely face and subscribe to my channel if you haven't done it already. Otherwise, thanks for watching, and hopefully see you in the next video.